Alright, so in this video, we're just going to be practicing some of the same calculations that we've already done in class. So for this specific example, we're looking at Stat 113 Exam 2 scores. So we took a sample of 13 students of mine and found the following results. So we have the 13 different exam scores. Our first question is to find the mean Exam 2 score. Right, so to find our mean here, so it's just a sample, so it's going to be our sample mean of y bar. I'm just going to add up all of the different numbers, so the 82 plus the 93 plus the 91, and do that for all 13 numbers all the way where I get my 65 and those 58 included. And then we're going to divide that by 13. And so when we do that, we're going to get that the mean Exam 2 score was an 80. Next, we're asked to find the 5-number summary. Well, in order to find the 5-number summary, the first thing I need to have is my data listed in order from smallest to largest. It's not already in that order, so that's the first thing I need to do, is to list my order. I didn't have to worry about that for the mean because it didn't matter. I just added all the numbers together. So first I'm just going to list out my 13 numbers in order. And then, of course, I always double check to make sure I have all 13 of them. Okay, so I have all 13. So now we're going to find our minimum is just the 58. Our maximum is our 93. To find the median, we're going halfway between. So that would end up being the 7th value when I cross off 6 on either side. So I should get a median of 82. We could also use the percentile formula to help us find that. So if you recall, in order to find our index, we take our k over 100, where k is our percentile of interest, times our n plus 1. So to find the medians, I would take 50 over 100 times our 13 plus 1, which would then give me the 7th observation. So I could just go through here and say my 1, my 2, 3, 4, 5, 6, 7th value there. So you can still use the index formula to find the median, as well as for Q1 and Q3. For Q1, let's first find its index. So for the first quartile, that would be the 25th percentile. So this is going to give us that we want the 3.5 value, which means I'm going to find the 3rd and the 4th, and then we're going to average those two numbers. So Q1 is going to be 73 plus 76 divided by 2. So the first quartile is going to be 74.5. To find our 3rd quartile, same idea, except for we're finding the 75th percentile, which is going to give me the 10.5th percentile, or value. So I have now got to find the 10th and 11th observation and average those two values to find my Q3. So I'm going to have 87.5 as my third quartile. So now we have our 5-number summary. We have our min, max, and median, Q1 and Q3. Next, we're being asked to calculate and then also interpret the standard deviation. As you've seen in class, I always make this little chart to sort of help me calculate things. So I'm going to have my value of y minus y bar, and y minus y bar squared. And then the first thing I do is just list each of my numbers. Here I'm just listing the sorted ones, though it does not matter the order I list these in. So there's my 13 values, all listed there. And then we're going to take each of those values and subtract off the mean, which was 80. So we're going to take 58 minus 80 and get negative 22. 65 minus 80 will give us negative 15. So this is just saying that that value is 15 points below the average score. 73 minus 80, so that person is 7 points below the average score. And just keep subtracting 80 from each value in this column. Now that we have all of those values, we're going to take each of these values and square it. So negative 22 squared will give me 484. Negative 15 squared will give me 225. Negative 7 squared will give me 49. And just keep on going for all of our values. So we have all of the values in this column squared over here. Now what I want to do, going back and looking at the formula for our standard deviation, is we have this big square root, and we have the sum of the y minus y bar squared, and we're dividing it by n minus 1. So the first thing I'm actually going to find again is this sum of the yi minus y bar squared. Because all that is I've done each of them for each individual value. That's just what the 1 to n means. So the first value, second value, all the way up to the 13th value. I have found this value squared for each of them. And then this capital sigma again just means to sum them up. So I'm just going to add up all of the numbers in this column. And when I add up all of those values, I should get 1,208. So that is what that piece of my formula is going to be. So now actually plugging that in, so my S is going to be the square root of 1,208 over our n was our number of observations, so we had 13 values, and we're going to subtract off 1. So we're going to divide that by 12. And then take the square root of that when you're done, and we should get just about right at 10, just a tad bit more. Now finally, I did also say to interpret the standard deviation. So our standard deviation is the typical distance from the mean. The mean is 80. So we're going to go out that standard deviation in either direction. Again, it's roughly 10. I'm not going to worry about the decimal for this one. So subtracting off 10 and then adding 10. would then tell me that the typical Stat 113 student scored between a 70 and a 90 on exam 2. So that's our page doing a lot of the calculations. On the next page, we're going to do a practice of some graphs. So first, we're going to go through and do a box plot, a histogram, and a stem and leaf plot. So we're going to do all 3 of those graphs. Again, it's always good to pause the video and try it on your own as well, if you would like. In order to create my box plot, what I'm going to need is that 5-number summary. So again, going back to our previous page here, I'm going to be using our min, our max, our median, our Q1, and our Q3 to create our box plot. So first, I'm just going to give ourselves a little scale to work with here. And so the first thing I want to put on here is my box. So that goes from Q1, which was 74.5, to Q3, which was 87.5, and that's where my box is going to be. Then the line in the middle is the median. Our median was an 82, so that's going to be about right there. Then I draw my lines out to my min and my max. So my max was a 93, and our min was a 58. And if you want, you can always label these values as well. And then I'm going to give myself on here, so these are exam 2 scores. Next, I'm going to create our histogram. I'm going to kind of work with the same scale here. So from 50, and just going up by 5s. And exam 2 scores. And so now we're just going to figure out how many numbers we have between each of those values. So up here on the y-axis will be our count. So I had one student score between a 55 and a 60. Or that's where that 58 is going to be. We had no student score between a 60 and a 65. Because it includes 60 but not the 65. The 65 will go into the 65 to 70 group. So we only have one student there. Then looking at our 70 to 75, we just have that score of a 73 there. From 75 to 80, we have a 76 and a 79, so we have 2 students that scored there. Between an 80 and an 85, we have 4 students that scored there. From an 85 to a 90, we had 2 students scored there. And then from a 90 to a 95, we had 2 students score there. And if you want to, you can kind of put those counts on top of the bars, because then I can quickly check. So 2, 4, 8, 10, 11, 12, 13. I have all of my 13 students. The scores there for me. Next, we're going to do a stem and leaf plot, but more specifically, I'm going to do a split stem and leaf plot. So for a split stem and leaf, I'm going to have 2 stem options instead of just 1. So if I'm going to have 2 5s, 2 6s, 2 7s, 2 8s, and 2 9s. And again, where I'm getting those ideas of my stems is it's everything but the last number. So mine ranged from 50 something to 90 something, so that's why I chose those for my stems. And then we're just going to attach the appropriate leaf. So our lowest score was a 58. So I want to attach an 8 to one of the 5s. All the leaves of 0 through 4 will go to the first stem, and all the leaves 5 through 9 would go to the second part of the stem. So the 8 will be attached to the second 5 stem. For our 60s, we only had 1 student score in the 60s, and it was a score of 65. So that's going to again go in the second stem, because that's our leaves of 5 through 9 that go there. For our 70s, we had 3 student scores in the 70, a 73, a 76, and a 79. The 3 will get attached to that first stem since it's between 0 and 4, and the 6 and 9 will be attached to the second stem since they are between 5 and 9. For the 80s, we had a lot of students score there. We had a total of 6. 4 of them are stems between 0 and 4. So they will all be attached there. 2 of the leaves are going to be attached to the other stem because they are leaves between 5 and 9. Lastly, we only have 2 students who scored in the 90s, a 91 and 93, so they will both be attached to the first 90 stem since they're between 0 and 4. Now, if you were to actually take a moment and sort of tilt your head, you'll actually see that this graph actually matches this one here, because we're going in increments of 5. So that's what we're doing, is sort of breaking up to have 2 50s groups, 2 60 groups. So we have 1 there, none there, 1 there, 1 there, 2, 4, 2, 2. So this is really doing the same thing as the graph over here was as well. All right, next we're going to go through and do those 4 characteristics of interest. So we want to talk shape, we want to talk if there's any outliers, our mean and median, and then our standard deviation. So first, by looking at our histogram up here, let's talk about what shape we would use to describe it. It appears to have 1 overall peak, so I would call it unimodal. Since most of the data is on the right-hand side and there's less data on the left-hand side, I would at least say that it's somewhat skewed to the left. We can also see that in our box plot because the median is closer to the right-hand side of the box. So this is where this 25% of data falls, versus this 25% is more spread out, and this one's even more spread out. So here's where half of the data is, and then here's where half of the data is. So it's more spread out on the left, so it's going to be more skewed to the left. All right, so when looking at how Dr. Herman's STA 113 students perform on exam 2, The data is unimodal. That we can only see in our histogram. We can't see the unimodal in the box plot. And somewhat skewed left. So then we would have our shape taken care of. Next, we need to decide if we have any outliers. This student here that scored that 58 kind of appears to be kind of all by their lonesome out here. So we'd probably think that that is an outlier. So with a score of 58. Next, we're going to our mean and median with those numbers we calculated earlier. So we have our mean of 80 and our median of 82. So our mean exam 2 score was an 80. And then the median cuts our data in half. So I could say with half of the students scoring above an 82. And then finally, we want to interpret our standard deviation, which we've technically already done right here. So I'm just going to write this same sentence here as well. So our typical score was between a 70 and a 90. So we have shape, we have outlier, we have our center of mean and median, and we have our standard deviation all covered. Now last, I'm just going to show you how we can confirm all of this in StatCrunch. So first, I'm just logged in to StatCrunch here, and I'm just going to open it. And then I'm just going to manually enter in my data, and I don't need to worry about it being in order. So I could just enter my original data before we actually sorted it. All right, so we have all of our 13 numbers there. Now first, to verify the numerical summary that we did, I'm going to go to Stat, Summary Stats, by columns, click the score that I want, and here I'm just going to click the different things I actually want. So I'm going to get my mean, I'm going to get my standard deviation, I'm going to get the median, the min, the max, our Q1 and Q3, since those were the numbers that we calculated. So now I can confirm that I got the same things when I did this by hand. All right, so looking at the numbers, most of them are the same. So we got the mean of 80. We got our standard deviation of 10.03. We got a median of 82, and our min and max match. If you notice, our Q1 and Q3 don't exactly match because StatCrunch actually does a slightly different method of calculating those quartiles than we do. And so I did want you to see this because the method that we use in class can sometimes give you different values. So I want you to do the method that we did in class versus what they're doing here in StatCrunch. That's just kind of a little thing to be aware of when you're actually going to use StatCrunch to confirm things, is that Q1 and Q3 might not exactly match. The method that they use, they don't actually use the percentile index like we do. They do a slightly different method where they actually include the median in both endpoints. but I don't want that to be your sticking point. That's why I wanted you to see in StatCrunch that you might not exactly get the same things, that you wouldn't panic if things didn't quite match up. But everything else should match up. It's especially nice being able to verify that you did the standard deviation calculation correctly. So again, just a little heads up about the quartiles may not match, so don't fret on those when you calculate them. And then if you want, you can always at least confirm the histogram. So in order to get it to match, like if you did this at first, it actually did end up matching ours, that they went by a width of 5. But you could also specify that. So for example, if you were to do this by hand and you wanted to do it by 10s instead of by 5s like we did, you could always change the width here to get it to match. Or if you're unsure if it's going to do it by the 5s, you could just force it to go by 5s there as well, so that you would get the same graph. All right, so again, hopefully the calculations feel a little bit better by hand after watching the video. Again, keep in mind with StatCrunch, I know it's going to feel a little awkward when the Q1 and Q3 do not necessarily match up. Sometimes it will, sometimes it won't. It just depends upon the sample size. But it's just something, again, I wanted you to be aware of as you're working some of your homework and stuff as well.